this computer. Okay. Anyways, we'll have to start right now. All right.
Maybe it's just a simple start video in your screen at the bottom of Zoom.
No, I tried all that.
Okay.
Yeah, you know what? It was a setting that I did. But anyways, we'll start. Okay, yeah. So right now I'm just going to play a short video that I thought was kind of interesting. Thanks to the help of Toronto RASC. It's a little short video. We'll just give people more time to join in. So far we have 31 attendees right now. So we'll start. Let's see if this works. I'm going to share my screen. There we go.
You should see a bunch of rainbows. But when you look at the source of the two lights, you should be able to tell also that they are two different colors. There's some interesting physics going on here that pertains to making sure that the light that we create doesn't pollute the night sky. The light on my left, on your right, is a daylight branded General Electric LED light bulb. And it has a specific temperature that it shines at. It's a bit of a challenge to explain, but the hotter that a light is, the bluer it also appears. When you use the taps on your bathtub, usually the blue side means cold and the red side means hot. But this is a little bit misleading. If you have a gas range in your kitchen and you turn the oven on so that the flame is nice and red, that means that the flame is pretty hot. But if you get it down to a blue flame, that means that it's very hot, unsuitable for cooking with. Well, in actual physics, the bluer a light appears, the hotter it is. This LED light on my left, on your right, is bluer than the one on my right, on your left. And these two lights have different uses. If it's wintertime and you have seasonal depression, or you're worried about making sure that you have enough vitamin D and enough sunlight, you should probably use lights like the one on my left that give you a nice hot spectrum. This light is giving you a color temperature on the box of about 5,000 Kelvin. The one on my right, on your left, is about 3,700 Kelvin. This is the kind of light that you should probably use in your house when you're getting ready for bed. This is a light that will not disrupt your biological clock in the same way that the one on your right does. The light that's on your right will simulate real sunlight, and it might throw off your biological clock. And there are some studies that indicate that this is not good for your health. Also, you should probably not use lights like the one on your right at night outside, because it'll fool all of the insects and all the plants into thinking that it's daytime as well. Also, the brighter that a blue light is, the more light pollution it creates due to particulates and wavelengths in the air. So I think you should probably try to choose lights that are using a different color temperature, like the one on your left here, the dimmer, yellower one. It'll still give you good color rendition, and you can tell that because of these glasses. When you look at the rainbow spectrum, you can see that there are different colors being broadcast by that light, and it gives you good reproduction of colors, just like the bright daylight sky. All right, I'm going to replace one of these lights. Okay, so this new light that I've just installed is a compact fluorescent light bulb. These were really popular for a little while, but they're becoming less popular now. I wanted to use this light bulb because it demonstrates something different is going on. The excitation of gases inside the compact fluorescent light bulb is causing those gases to fluoresce at specific wavelengths. And so whereas when you're looking at the spectrum that's produced by the LED light bulb, that's producing a wide range of colors in a continuous spectrum, the CFL light bulb is producing several discrete colors, one red, one yellow, one green, and one blue. So this is not quite the same physical process that's going on that creates those different colors. All right, now that we've all seen these light bulbs, I'm just going to put a cover on them. All right, I've taken the glasses off. Obviously, the light bulbs are still shining, but now they are under lampshades. And now I want to talk a little bit more about the legal definition of light pollution. I've got here a copy of the Town of Richmond Hills Light Pollution Control Bylaw. This is the first bylaw in Canada whose purpose is the control of light pollution. The reason why we have this bylaw here is for the protection of the David Dunlap Observatory. Now, there's a certain amount of legalese in the document, but the broad strokes of this are that with exceptions, lights that are set up outside should be broadcasting no more than 2% of their light over the horizontal. Also, there's certain restrictions on the spectrum of light that's being used, partly because of different kinds of light bulbs being more suitable for use at night. Also because certain colors of spectrum from these light bulbs can interfere with observations being done at the observatory. And this document is now more than 20 years old, so some of the technology's changed. This document doesn't say anything about LED lights because 20 years ago, LED lights were not being used in consumer electronics or for your lighting your home. I'm not sure if it's time to update the bylaw. We know that that's somewhat of a fraught process, but we're glad that we have the bylaw nonetheless. So I want to make sure that you're aware when you go home that if you have any lights outside of your house that are shining some of their light up into the sky like this, or so that you can see the naked filament of the light bulb, or if those lights are broadcasting some of their wavelengths into the air at wavelengths that are necessary for the use of the observatory, you should expect a visit from your local bylaw enforcement officer, and you might get a fine. So please be friendly to the David Dunlap Observatory and don't use light bulbs that are against the town's light pollution control bylaw. Thank you.
Okay, ready to roll.
How did that, Jade, how did that turn out? That was okay for the audio? Did it seem okay?
Yeah, I just said crank up my volume a bit. I don't know how well this volume of mine is coming over, but we'll see.
Okay.
Yeah, it's good.
Okay. Well, anyways, we'll start with the main presentation. I'll make the announcements, and then I have what's up with Jay, followed by here. Actually, I'll share the screen, and we'll do this. And hit 5, is it?
You were fine a minute ago.
Was it fine? Because it didn't show, was it a full screen?
No, it's not. Hit F5 and see what happens.
That's what I'm trying to do.
Don't worry about it. It works fine the way it is.
Okay, you can see it?
Yep.
But the full screen?
Nope, but it doesn't matter.
Because it's just not allowing me to start.
I'll just go from one slide to the other.
Wow, this is so much for this update here they have. Because I can't start it.
Start it before you switch the screen. Oh, I don't know. You can't do that again.
Try starting it and then switch the screen to wherever it's playing, like before you share the screen.
I'm going to stop it. Yeah, well, it's not allowing me to do it.
Okay, then run it without running it full screen.
Well, so much for that. Like, it's nothing works like the way it should.
Just run it full screen. Run it the way you had it.
Wow. Okay, I'm really having difficulties with this. Anyways, okay, we'll run with it because I have it open. Okay. Let's go here, there, share that.
Okay, just click from one screen to the other on the left side there.
Okay, so this is what we have lined up for you guys. I don't know what's going on. There's a new Zoom version out, and it's not allowing me to run it. I do have it open up right now, so this is the best I can do and try to figure out what went wrong. Okay, so this is our lineup. We'll take a short break after what's up and what's new, and then we'll have the feature presentation with Scott, but it's no longer Mars. It's what exactly, Scott, is it?
The show is called The Secret Life of Stars, narrated by Sir Patrick Stewart.
Okay, sounds good. Okay, we'll move on. Okay, so, okay, because of recent events, you know, this is the official statement from the National. So basically, what they're trying to say is the society, the National, is working on every angle that they can regarding about the recent events, and they do have someone in place. I can't see the screen here because it's not allowing me, but just take a moment to read out, or just read it to yourself. I'm not going to read it out to you, but this is what the official statement has for the National. All right. Okay, so anyways, we'll move on right now. Okay, the barbecue. We had a council meeting regarding about the barbecue. We delayed it to July the 18th. Should be around 6 p.m. The location should be St. Vital, and there's a reason why we decided to have it at St. Vital. One thing, the washrooms do get wiped down. And of course, it's the whole idea that we get about 30 people, 35 people, we can maintain our distance between everyone, keep the 2-meter distance between everyone. But unfortunately, we're going to need some barbecues. So if you're able to contribute, bring a barbecue, please let me know, or a council member, that would be great. But hopefully it will still be on. Another problem that we might have with this barbecue, and we might delay it again, is because of the recent riots happening, especially in the States, there might be a spike in the COVID-19. So that's why we delayed it for another week. But of course, we'll keep everyone posted regarding it. The website. I noticed some people are having some problems with the forums. Well, basically, if your membership has expired, we do give a 60-day grace period for it, which means that you still have access to the website. But once you stop having access to the website, you won't no longer be able to access the forums and some of the other functions. So it's not that the forums are not working, it's just your membership has most likely has been expired. And there should have been a notice going out to everyone that their membership has expired. So just let everyone know about the website. Again, there's some confusion with Glenn Lee. There was an email going out. Yes, it is open, but we do have some restrictions. If you're going to use the surfaces or the washrooms, I did leave a pine sol there and some wipes, so you're going to have to wipe down the surface. Please maintain the practice of 2 meters or 6 feet apart. We're not allowing more than 5 people really on the pad at one time, no more than 2 people at the warm room. And right now, the LX200 isn't working, but again, there should only be 1 person allowed in the dome at one time. That could all change with phase 3, but we'll see what phase 3 is going to mean. All right, we do have the virtual Boston Pizza today at 9 o'clock, right after this meeting. Of course, everyone, it's a meeting, not a webinar, so everyone's free to contribute. I'm definitely gonna have a beer after this, after all these little problems that we have here. So maybe 2, and I do have some pizza standing by. So let's have some fun, and it's open to everyone. Feel free to chat amongst yourselves. If some of the members got any questions, please ask. Members night. Of course, the next one, it really shouldn't be until August, and the reason is because it's summertime, and it's not gonna be dark enough to really view anything. And of course, as COVID-19 doesn't really help, but I will mention that, and we are working a way to get internet access to it, so I can maybe do some webcasting. If this works out, great. I'll keep the members informed, but that's another thing that we are trying to work out right now. Hopefully we'll have some more Zoom events, but we'll have to wait and see how it turns out. So that's all I have to say. So let's stay home, stay healthy, and stay safe. Right now, I'm going to pass the screen on to Jay.
Thank you, sir. Speak to me, oh great computer. There we go. How's that showing?
Good.
Good.
Okay, here we are. We're done do a two months, June, July, August, half of June, all of July, and half of August tonight. Mostly because we won't be having a formal meeting if we go ahead with our plans to have some kind of a picnic next month. It's kind of an interesting month, although the exciting stuff that we like to have, such as comets, isn't happening. At least not very much. Okay, now give me next page. Wouldn't you know it? I found out one thing about this. There we go. Start off with the lack of darkness. Sunsets at 9:37 and sunrises at 5:19, but in between, we never get dark enough to be called astronomical night, which requires the sun to be more than a certain number of degrees below the horizon. 2 months from now, on August the 7th, we start to see sunset now before 9 o'clock and rising after 6. And at that point, we'll have 4.5 hours approximately of darkness. So anytime after July 11, we start to get dark about 1 o'clock in the morning, dark enough at 1 o'clock in the morning to be formally known as astronomical darkness. Although I pointed out last month that even if you don't have that kind of darkness, you can still do short exposures and certainly visual observing if you're looking into the southern part of the sky. And just to reiterate what they are, as you're moving into darkness, as you see it on the left and right side of this chart, then you pass through civil twilight, which is what regulates when your headlights have to come on, nautical twilight, and finally astronomical twilight. And at the end of that, you're into nighttime. We have a sunspot. They've been slow in coming, but if you're following spaceweather.com, you know that they get a little excited every time there's a sunspot on the sun these days. And they made the point that we've had 11 days this month with a sunspot. It's been the same sunspot almost, but anyway, you can take a look at the sunspot chart there. It looks like we're now at the bottom of the old cycle and the start of the new cycle. And the sunspot you see on the screen there, 2765, is actually the part of the new cycle. And you know that because it's not near the equator of the sun, which if you across the middle, it's at a low southern latitude. And when the sunspot cycle starts, it starts in the southern and northern latitudes and works its way toward the equator. And it also tell from the shape of the magnetic field that it's part of the new one too, but that's not visible in this image. On the southwest horizon tonight, well, you can see from the shape of the screen that's a little bluey, and that's because Starry Night is trying to tell us that at midnight it's not particularly dark, although it's not too bad looking south. We're seeing leaving the zone of the galaxies that tend to be here underneath Arcturus in Virgo and Leo. And right now, the most prominent star is Arcturus, which you find by following the arc of the Big Dipper's handle. So arcing to Arcturus. But we have coming up in the east 3 stars, Deneb, Vega, and Altair. And those, of course, are the summer triangle stars. And they are sort of a marker of the friendliest time of the year to do astronomical observing for 2 reasons. It's warm, and secondly, got all this star stuff that's coming up in on the east side of the sky. So we take a look tomorrow morning. You can see off to the right-hand edge here, the Milky Way's moved over there, but what I particularly want to show is at 4 a.m. tomorrow, a pretty full moon will be passing underneath Mars, and Mars is now getting pretty bright, so it's a little bit of a pretty picture, sort of with very little advance warning. Of course, if you stay up all night waiting to look for noctilucent clouds, then you'll be well positioned to look at the moon and Mars tomorrow. Better deal might be to wait for 4 months and Mars is up in the evening. If we go forward a month, you can see that our Milky Way has moved over now at midnight. This is slightly offset, so it's now due south at midnight, the bright part of the Milky Way, and all of the dust and gases up through. And here we have Deneb and Altair and Vega, the summer triangle stars, now getting into the center and high part of the southern sky. And at the same time, we're saying goodbye to these guys with all of the galaxies in it. Also, we're starting to see the 2 bright planets, Jupiter and Saturn, coming up at midnight, and they will be moving over into August, which we'll look at in a minute, so that they're becoming more and more prominent in the evening sky. And not far behind them is Mars. So here we are looking in at August the 13th, 2 months from now, and you can see Jupiter and Saturn both together in the sky here. And they're following along with each other. They're going to be like that all summer, gradually separating a little bit, about 5 degrees apart now and going up to 7 degrees at the end of August. And here's Mars trailing in behind. But Mars, of course, getting pretty bright. It's below magnitude -1 at this point. So it's actually going to be brighter than Saturn and getting up close to the brightness of Jupiter. So we'll actually have, by the time we hit the middle of August, some fairly nice planets up. Good for any star parties if we can ever get to any of them, especially if you're showing stuff to the public, because those two planets, Saturn and Jupiter, are one of the showiest couple of planets in the sky. Judy and I have been going out looking for noctilucent clouds. The season has just started for them, and there's already been some pretty spectacular observations out of Europe and out of Edmonton 2 nights ago. One thing you really need for noctilucent clouds, they're so high up in the atmosphere where there's so little moisture that it takes extremely cold temperatures to form them, lower than minus 120 Celsius. And you can see on the left-hand side here is a graph of the temperature in the mesosphere, and the temperature, the curve for this year is this dark one. Sorry, the red one here coming down, and you can see that it's colder than any other temperature in recent years. This goes back to 2007. So in effect, we're setting record cold temperatures in the mesosphere at around 140 degrees Kelvin, which is minus 170, 33, minus 133 Celsius. At the same time, this is a measurement of the moisture in the sky. And you can see the amount of moisture has been climbing up as we come into the season. DOY stands for the day of the year. So your sun has to be at least 6 degrees below the horizon before you start illuminating. At 6 degrees, you can illuminate noctilucent clouds that are actually more than overhead. But because they tend to be in the north, we very seldom see noctilucent clouds in the city higher than about 45 degrees. So after about 10:30 in the evening through July, you can see noctilucent clouds. After that, the sun will be low enough, but it's probably better to wait until 11 or 11:30. By the time we get into August, the whole thing is an hour earlier than that. Just to get an idea what they look like, you have to be careful to distinguish noctilucent clouds such as these white pearly fibrous things from regular cirrus clouds. In the upper right here, this image, the dark clouds are regular cirrus clouds. On the other hand, in the lower right image, the noctilucent clouds are so bright that they really silhouette the lower level clouds. We look at the planets. Mercury is low, probably not really visible because at 10:30 it's really only just starting to get dark. So we have to wait until we get into August before it gets pretty good. And in August in the morning, it looks like a pretty good apparition of Mercury. It'll be nicely visible. Venus is moved out of the evening sky, is now in the morning sky. You can see in my diagram on the upper right the size of Venus on June the 13th and the shape of it, a very narrow crescent tonight or tomorrow morning, versus what it'll look like 2 months from now, quite a bit smaller, probably somewhat around quarter, or rather half to a third the size currently is, and it'll become more fully illuminated. At the same time, Mars is doubling in size, although it's still not really huge, going from 7 arc seconds to 15 by the time we get into August. I should point out that the size of Mars in these diagrams is not on the same scale as the size of Venus. Venus is probably close to 50 arc seconds in that big image, and Mars on the left-hand side is at 7. So. But anyway, the fact that Mars is getting bigger is going to make it much, much easier to observe, and the fact that it's moving into the midnight hours means that it isn't going to have to get up quite so early. You can see that by August it'll be arising at 11 p.m. approximately. Jupiter, easy to find, bright thing rises after midnight, but as we get later and later on in the summer, it's going to rise finally in a decent hour in the evening in August. Saturn, not much very far behind it, so it'll do the same. And so we'll have those two for evening observing in late summer. Uranus is not very good, not well positioned June and July, but it's going to be really in dark skies in the latter half or quarter of July and all through August and beyond. Similar, Neptune is up in the morning. In fact, it's just above Mars right now, but it'll be drawing away from Mars to the west, and but it'll be in the dark part of the sky through the whole summer. Well, a lot of what we have coming is the apparitions of Venus and the moon. Here we can see the June 19 situation. So 4, 5, 6 days from now, Venus here, and the moon is not very visible because it's an extremely thin crescent. But that makes for some really interesting pictures if you want to get up at as early or as late as you can to see the moon in a sort of semi-dark sky where it'll make a good photograph. Venus, remember several months back, Venus was passing through the Pleiades. Well, now it's passing through the Hyades, which is a much more scattered cluster of sort of 4th and 5th magnitude stars here. And Venus itself has been moving along this way, passing through them. I'm showing you here it on the 12th, which after it's passed through the Hyades. And it's now just above Aldebaran. So there'll be some pretty scenes in there with those stars and with Venus, and as usual, a challenge to photograph very bright Venus against the Hyades cluster. But bracketing your exposures on a sort of modest telephoto lens or even a 50mm lens would probably get you a pretty decent picture. We got crescent moon, Venus, and Aldebaran in July the 17th. And August 15, we got a crescent moon and Venus again. Here's a picture. This time the moon, dark side of the moon shows up with a very thin crescent on the leading edge. On July the 6th and again on August 2, when the moon comes around, Saturn and Jupiter will be in the sky with the full moon. And on July the 6th, Mercury and the moon will be together, but Mercury, as I indicated earlier, is so low in the morning sky at that time that it's probably an event that you can miss and wait until you get into August to look for a similar meetup of those two. We haven't got much in the way of comets in spite of the promise of the last few days, and Old Faithful Pan-STARRS is still hanging in there at -8. You can see that, or +8. You can see that in the graph here. It's more or less at its peak. Tonight and for the next couple of nights, it's actually inside the bowl of the Big Dipper. And so it's not particularly bright, but all you have to do is point your telescope into the bowl of the Big Dipper and you'll spot it. And it does have a decent tail in photographs. You can see from my graph here, it's not showing in the Dipper because the Dipper's been rotating. This is the end of the time period at July the 31st here. But you can see that Pan-STARRS is gradually dropping southward down toward the horizon away from the Big Dipper over the next month and a half. So it's going to start fading away in another couple of weeks or in a week, but in the meantime, it's certainly a real easy comet to find. We have another one, Comet Neowise, one of these comets that's found by a particular telescope program. It'll come above the horizon in mid-July in the north. So as soon as it's above the horizon, it actually becomes circumpolar, although you won't see it in the daytime. Mid-July is still pretty bright times, but here it is through July, and you'll see that it sort of gets up and arcing across parallel to the north horizon. But it will be fading fairly quickly as it comes above the horizon and be down around 8th magnitude or something like that, according to predictions. But you'll notice that when it's first over the horizon, current predictions have it as magnitude 3 to 4, maximum magnitude around 2 to 3 as it passes the sun, not quite visible to us. Interesting that the comet is in the north because that's where the sun is and not very far below the horizon for us. The weather for the next 10 days, you can look at these. We're sort of getting a slow increase of temperatures up to normal or slightly above by the middle of the month, and then hanging there. No really warm weather coming. They're showing some wet weather with lots of cloudiness after tomorrow. Neither of these are too reliable, but the rain has been coming on some of the bigger predicted days. So maybe Monday and Tuesday night to Wednesday could be wet, but I don't know if I'd put too much faith in the cloud cover. And with the cat, we're done for now.
Oh, sorry.
Okay. Oh yeah, Brian, you get caught short.
Sorry, I needed to step out for a moment. Hey, thank you, Jay. That was excellent. So, all right. Okay, so Michelle, you're next for what's new. So, what's happening in the world of astronomy?
Okay, one sec. Can you see my slides?
I see your computer screen.
Ugh.
No, we still have Jay's screen shared.
Well, it's letting me share the screen.
I'm seeing Michelle's screen. I'm not
Yeah.
sharing anymore.
So, did you start your PowerPoint?
I'm sharing now.
There we go.
Can you see my PowerPoint slides?
Yep.
Yes, I do.
Okay. So I've selected a few items again this month for what's new. There's tons of items out there. The cover here is of the ALMA Observatory. It's 5,000 meters above sea level in Chile. That way the air is stable. Okay, so the image on the right here is from ALMA, and it's in a star-forming system. So these are actually stars or little solar systems in the middle of forming inside this cloud. Now the thing about is this nursery is got dust, so you can't see it optically. So what you're seeing is a radio image that's actually ALMA's frequency is somewhere between radio and infrared. It's in that area where the two are. So this group here was studying this binary system that's in the midst of forming. Here is a diagram on the upper right of this picture of our solar system, so you can get an idea of the scale. So basically, these two objects are roughly the separation of Pluto. Yeah, here it's ALMA telescope, 66 dishes, 16,000 feet. And these are sort of dark nebula, and this one's at 460 light years away. And I bet you that's Boston Pizza calling me for pizza to pick up. Nope, it's not. Okay, we're good. It should be here shortly, but hopefully I'll be done soon. So yeah, let's see, what else is here? So 460 light years away. And so this is that was a zoom in of this area, and it's actually part of a trinary system. So there's a bigger star here, and then these are down here. So when you look at this image, the actual orbit of these two is about 360 years to orbit, similar to the orbit of Pluto. Oh, it is my pizza. Okay, I'll be down in a minute, I guess. Yeah, tell me I'll be down.
All right, so we'll just take a short break right there. So Michelle can grab her Boston pizza. All right, can everyone hear me? Okay. So Michelle, again, got any questions? Please let us know. I don't think I have any questions.
Sorry, Brian, I wasn't watching the screen here.
Yeah, sorry about that. Just answering a question. All right, so I don't know what happened to Michelle. I guess she's paying for the Boston pizza right now. All right. Okay, so I think Ken was asking a question. And I'm trying to get the panelists here. Ken?
Hello.
Hey, Ken, do you have a question? I think, Jay, are you with us right now?
Yeah, I'm with you.
Okay,
Jay,
so question right now.
Jay, I was just wondering, do you know the tilt of the rings on Saturn for viewing?
Well, I see somebody answered that in the chat with a number of 20 degrees. Oh, Scott.
Oh, I don't see it, but thanks anyway. That's what I wanted to know. Thank you.
It's just a number. They're pretty nicely opened, actually. So they're still pretty attractive as it's getting up into a better time of the year and night to observe it. It's also, because it's moving up the ecliptic, it's getting higher and higher in the sky at night instead of languishing down there in the basement the way it has been for a year.
And Ken, it's Scott. I did answer your question, but I see that I only sent it to all the panelists, which you weren't one until just a moment ago. So sorry about that. That was me.
Gotta love technology.
Do you? Do you really?
I guess Michelle was pretty hungry. She stopped to eat that pizza.
Yep. We only have one video screen working and it's mine. So
I'll have to see if I can find something on my computer screen here to.
like I should be allowed to click on you and turn your video on, and it's now allowing me to. I even restart the seminar saying your video is supposed to be open, but it's not. So obviously this version 5, if anyone downloaded it, doesn't work very good. So, because I should be able to, as being host, turn it on and off as I wish.
Just thought it'd be a lot of fun when we try doing it when we're having some beer and pizza.
Well, everyone's going to be turned on. So it's a meeting, not a webinar. So.
You know, Brian, a year from now, almost exactly, we have an annular or eclipse over in Northwest Ontario.
Northwest, okay.
It's, and I'm just gonna call up some maps here and I'll share them. See if I can find something.
So that'd be 2021. Okay, I made a note here. So eclipse, that's pretty close. Like, is it a partial, full, or?
Annular, here, let me share my.
Angular.
Yeah, it comes as close as Thunder Bay, I think, hey?
Just a little north of them. Let me share my screen here. And I'll see if I can find that image. It's where? Here, here we go. So this is kind of a convoluted, is that showing up?
Yeah.
So here the track starts over here. This is the sunrise line, and then it travels across the north and it ends in Kamchatka in Russia. But you see, Thunder Bay is here at the sort of eyeball of Lake Superior, so you have to go north from Thunder Bay. And actually, Armstrong is the one community that's just inside the annular eclipse zone. One of the interesting things about Armstrong is you can take the Via Rail train there from here. So you can actually go to Armstrong and overnight catch train back the next day, depending on the schedule. Or if you feel like doing something exotic, you can go into the Belcher Islands, but that's tough because there's only 2 flights a week into there. You can go into Iqaluit up here and numerous other small communities in the north if you have a hankering for it. And if you're in the armed forces, maybe you can get up to Alert and watch the thing there. But for the easiest place to see it is right in here, just on the north shore of Lake Superior, because the Trans-Canada Highway goes through there. So for that little tiny notch just north of Lake Superior, you can sit on the Trans-Canada Highway and watch the annular eclipse. And because it's on June the 6th, 7th, 8th, something like that next year, the sun's going to rise very early, so you'll be watching that eclipse at 4 in the morning or something like that. So, and it'll be right on the horizon, so you'll want to try and find a place with a fairly decent view out toward the northeast, which is the direction the sun will be rising. When you look at the weather, though, you won't find it to be quite so favorable, because that's pretty cloudy, although it's more of a thunderstorm type cloudiness. Here is a picture from the satellite last year showing the conditions, and this would be very good because you can see most of northwest Ontario is clear, and even across Hudson
The
Bay.
satellite picture isn't showing.
It isn't showing. Okay, I guess.
Okay, I'm back.
Okay, well, anyway, there's something for you to do.
How long is the eclipse though? Like what's the projected time?
It's be of the order of 4 minutes or something like that.
4 minutes. Wow. Okay. Now that's something. Okay, so Michelle's back. Okay, Michelle, we'll let you continue on with your presentation.
Okay, I'm just gonna attempt to screen share again.
How's your pizza?
I haven't opened it yet. It looks good. Smells good. Can you see my presentation?
Yes, this hit full screen and or play from current slide. There we go. Okay, we got it.
Okay. Okay, so I was on this image here, and this is just a slightly more detailed image. It's kind of hard to see here, but all this haze here, they say it's like a chaotic gas because of the interactions going on between the two systems, and they suspect this gas is also feeding these two systems that are forming. And it's basically these systems are roughly the same mass as our star. So this is 1 solar mass and that one's 1.4 solar masses. And the dynamics, you can actually, by doing spectroscopy, you can measure the different gases because they have certain absorption and transmission spectra. So there are organic molecules in here, and this shows sort of a map of the different types of things they find in here, like carbon sulfide and so forth. Now, the spectrums are actually Doppler shifted or red shifted. So what that means is that this red is receding and the blue is advancing. So you can actually get an idea of the dynamics and how the gas is mixing. And you can see the system is kind of rotating out towards us. So that's interesting to know because I mean, working at the University of Manitoba, I'm learning a lot about how much information you can get out of an image. It's actually quite amazing. So here you get optics, some you get electron flow, all sorts of information you can get from these images that are available to everyone online, like Chandra telescope pictures and so forth. Okay, so that's the study these guys did of this particular system. Next, New Horizons has now done, we've done this long baseline parallax. So what you're looking at here, say Proxima Centauri, all these stars in the background are much further away than Proxima, so they appear stationary. And what you're looking at, whoops, ruined my surprise. What you're looking at here is the view of this from Earth with respect to the star background, and then New Horizons, and same for Wolf 359. So actually, if you go to New Horizons website, you can get these images. You can also get them for those, 3D glasses, the red and green eyepieces. So you can do that, or you can make a stereoscope and look at them. So just as a reminder to some people as what parallax is all about, I found this really nice picture here that shows the Earth and the New Horizons probe, which are about 4 billion miles apart, or 43 AU, which is Earth radii. And if you look at the star from this position, you see it at this angle. You see it appear over here. But if you look at it from here, you see it appear in the opposite direction. And in fact, using this and knowing the distance, you can actually, the distance between the two observers, you can actually measure the distance to that star. So that's what the parallax is all about. And in fact, it's used to measure distances to stars where we have the precision to do it. So if we're orbiting the sun, we can take a parallax measurement at when we're one part of the orbit and the extreme part, so 2 AU apart. And that baseline allows us to measure certain distances. It's only accurate up to a certain degree in our instrumentation, and we have to do other measurements to measure further distances. So this is just to give you an idea of the solar system and where these local objects are. So Alpha Centauri is roughly within our plane of ecliptic in terms of line of sight, and is part of this system. So we're actually looking at Proxima Centauri. And then Wolf 359 is in the opposite direction and just slightly above the plane of the ecliptic. So it just sort of gives you an idea of the view, and then you can see the shift here, and then these stationary stars in the background because they're much further away. So I thought that was kind of cool. So New Horizons is still out there, busy measuring dust and all sorts of things, and doing fancy experiments like this. So this is the longest baseline parallax measurement we've ever done. So this subject, I'm going to spend just a bit of time on it, and this is the last subject here. It's a fast radio burst. Fast radio burst is some energetic event that occurs somewhere, and we measure it as a burst of radio frequencies in a radio telescope. They last on the order of milliseconds, or 1/1,000,000th of a second, which is incorrect. That should be a thousandth of a second. Millisecond, yeah, my bad. That's a microsecond here, so this is wrong. It's 1/1000th of a second. And within that time period, that burst of energy can put out as much as our sun in 10,000 years. So that's how much energy is packed into one of these bursts. And they tend to be way outside our galaxy. So there's been measurements of several hundreds of these now in more recent history. But repeaters are very rare. There's like a handful of repeaters. And this particular one here, which is 121102, is a repeater that repeats every 157 days, where you have 90 days of activity and then 67 days of silence. It was discovered in 2014, but its repeating nature wasn't discovered until 2016. The reason the periodicity is important because we don't know what it is, so it will help rule out certain models, such as a precessing neutron star, for example. It doesn't seem to fit with that at the moment. It's interesting because historically, these kinds of things, every time we turn our eyes into the sky and look in different frequencies, we see these things and we have to figure out where they are. About 10, 15 years ago, the mystery was gamma ray bursters, which turned out to be stars being fed into, like regular stars being fed into neutron stars and causing these bursts. Although when the military put up their satellites to measure for nuclear testing, they thought nuclear bombs were going off every second, and it turned out to be these gamma ray bursts. That's actually how they were discovered. So this was done at the 76-meter Lowell telescope, and this is just to give you an idea of the scale. There's a person right there, and here's the telescope. Now, about 2 years ago, I worked at McGill University on the CHIME FRB telescope. The CHIME telescope itself is mapping the anisotropies in the microwave cosmic background. The fast radio burst experiment is a piggyback experiment, which uses the signals that come out of there to measure gamma ray bursts, and we call it a pipeline. And I designed a database at the end of the pipeline which collects that information. And my last week there, when we just turned on our system, and it was not even fully on, we discovered an FRB. And then scientists are like trying to herd cats. So they immediately started looking at the database and wanted to go through there and weren't working on the telescope anymore. And I got a nice compliment, which was, hey, nice database, which was good. Mainly because if that didn't work, well, that was my job and they need the data. So, so the actual experiment is located in Penticton, BC at the DRAO Observatory. And the Okanagan Valley, if you're not sure where that is. Okay, so because I worked with this group, it's a fair size collaboration. Actually, that's me right in the back there. So there are many publications that come out. So this is one of those publications that I'm part of. So you can see my name here amongst all these other names. I believe that's listed in alphabetical order, but it depends on the nature of the paper. There's an entire policy. So this was published in the Astrophysical Journal. And just a small excerpt from that paper is one of those one signal of 8, I think it was 8 different sources it said there. So this is the diagram. I'll just quickly explain. So what you have here is some fast radio burst of event that's occurring. And it's like one big spike of energy at different frequencies that's happening. And when it travels through space, it interacts with the medium in the space, interstellar or intergalactic medium. And what that tends to do, what that tends to do is slow down the lower frequencies and allow the higher frequencies to arrive first. So when you look at this graph, this is just an overlay. The higher frequencies arrive earlier in time and then the lower frequencies. I think I got that right. I always get it backwards. And these are the actual signals here that you see in the telescope. Now this telescope that I worked on has 4 cylindrical dishes with 1024 feeds. And so these are formed into beams. So there's 4 times 1024. And each one is looking at the sky simultaneously. So this would be from a particular beam or in that scope. So you could see this typical event that happens. The other thing is that there's certain things like in the cell phone band and TV band that we lose signal from there. It's just too noisy. And in fact, they have just like earlier we're talking about light pollution and stuff like that. Around DRAO, they have certain laws about using microwaves and stuff, although they know people are, they shouldn't be, but so these things end up messing up the signal also. So these bands in here are breaks in the signal that you have to deal with. You have to clean the signal. Sometimes you also get lightning in the signal. So this is what a typical event looks like. This is just the sum of the intensities. So that's sort of a profile of what it looks like. And the frequent time. So basically as matter travels through space, it interacts with space and different frequencies interact differently. So what they have to do eventually is they correct for this, and you get this one peak for all across all these frequencies. And that's what you use to characterize your source. Also, the shape of this peak is related to the distance to the source. So that's the other thing that you can gather from that, with a lot of assumptions, of course, in astronomy. So anyway, that summarizes my talk. And this is just a aerial, they took this some time back. This is actually a drone footage of the DRAO site. So you can see there's a little linear telescope array here. And the main building is over here, and you can sort of see this moving in on this. These containers here, there's a lot of electronics in here, thousands of wires and so forth. So anyway, that is what's new. Any questions?
Doesn't look like we have any questions, Michelle.
Okay.
So we'll stop it right there. Thank you, Michelle. I had no idea that your name is up there, so that's pretty impressive, if you ask me. So nicely done.
Okay.
Okay, so we're going to take a short recess, see if I can get everyone's video working, but if I'm right, I don't think I'll be able to. So anyways, we'll take a quick, maybe a 3-minute break so we can start Scott Young's presentation. So we'll see you in about 3 minutes.
Brian, a minute?
Yeah, go ahead.
Somebody asked a question of what we would see in Winnipeg with the annular eclipse next June the 10th.
Okay,
Be
answer that.
94% covered here.
94. Wow. Okay. That's if it's not cloudy. All right.
Yeah. 5 in the morning.
5 in the morning. Okay. Wow. Okay. All right. We'll just take a 3-minute break. So we'll make it. We'll come back at 8:50 p.m. All right. I'll see you guys in about 5 minutes. Hi, Scott.
Yep.
Okay, so we're taking a short break right now, so we should be back by 8:50 p.m.
Yep.
Sorry about the delay, but
It's no problem. It's all good.
yeah, I looked at the instructions again, and it's not telling me how to undo the video. Like once I set it in the original settings, but anyways, that's something okay with this new version. Anyway, it's a
Yep.
learning experience.
That's okay. We can share the screens. That's what matters.
Yeah, I'm shocked that previous to the updates, I was able to close your video and start it, but for some reason I can't do it anymore.
Oh, well.
And I'm surprised that as a panelist, I should have control over it. But anyways,
It is what it is.
it is what it is, yeah. So I'm gonna make a complaint to them, saying like, how come I have no control over the video being the host?
Oh, I'm sure they just put it in a much more convenient, totally hidden place.
I checked
Well, it'll work.
everything possible, and it's like, it's not working.
It better work for the Boston Pizza thing.
It's a meeting, so
Yeah, it's different
Okay, we'll
software, so
see.
you're good.
We'll see. Oh, okay.
okay. All right, that didn't help.
Let me try. Nope.
Yeah, it's just not allowing me. Okay. I even tried going back to the actual settings to like start up the meeting and change the settings on it, but no, once I disable the video, it's disabled for good, which is not right.
Hmm.
And I clicked on more, and it still isn't doing more. Make host. I can try making you host right now, and see.
Yeah, sure.
Okay, so you're a host right now. See if you can turn on your video.
Oh, look at that.
Nice background.
Yeah, thanks. It's a good thing I was ready for that, and I was wearing, clothes and a hat and stuff. Otherwise, you'd see the bad hair day.
At least your background's working. I tried that and it doesn't work for this laptop. But
Oh yeah, I splurged and we got a green screen.
no, really.
Yeah, we were doing enough of this for work that made sense to drape it up behind me, and that way nobody can see the weird stuff I have on my walls.
Okay. Well, it's 8:50,
Okay,
so let's start your presentation, please.
great. Well, hi everybody. My name's Scott Young, and I'm, for a few more weeks anyway, the senior planetarium producer at the Manitoba Museum. For those of you that have been to the planetarium recently, before all this hit, you know that we have a digital star projector, Digistar, as well as our old star projector Marvin, the old Zeiss, which is still there and still functional, mostly functional. Unfortunately, with us being closed, we can't use Marvin. But the company that makes some of the planetarium shows, Evans and Sutherland, has made a number of them available for planetariums to stream while they're closed. And so over the last few weeks, we've been premiering a number of different shows that we can basically do sort of a live premiere where we show it live on our Facebook stream, and then people can click on the link afterwards and watch the show whenever. And that way, I mean, it doesn't get us any money. We can't sell tickets. It's non-commercial, but at least it gets the planetarium still in the minds of its visitors and things like that. Now, the museum galleries are reopening tomorrow. We're going to be open weekends through June, and we're waiting to hear from the province when movie theaters can open, because they have decided that the planetarium, the closest thing it fits to is a movie theater. And so as soon as you hear movie theaters open, that means the planetarium will be able to reopen as well. Although, check our website and we'll let you know what exactly is going to be available. So today we're going to be seeing a show called The Secret Lives of Stars, and it's really about the life and death of stars as seen mostly throughout our Milky Way galaxy. It's narrated by Sir Patrick Stewart, who, as far as I'm concerned, could narrate every planetarium show ever, and it would be wonderful. He's just got a great voice. But it's a pretty good show. I'll do some screen sharing here. Hopefully we can make this technology work. Would be awesome if we could. Now, if there is any kind of internet glitch in my internet, because I'm actually streaming this up, if there is a glitch, I will put a link in the chat window in just a moment that you can click on and just watch it on your own, and that link will be valid all the way through June for sure, and maybe beyond that. So if people miss this, they can still get a chance to see it as well. So let's see if I can get this working here. Hang on, I'll share my screen. That's the one we need, and we'll share the sound. Isn't it great when I narrate the technology too? Okay, so here is The Secret Lives of Stars. And if you have any questions, throw them into the chat window or in the Q&A window, and I'll try and answer them during the show or afterwards. And again, there'll be that link in the chat window.
Most people around the world know the name of a famous star. Most people around the world know the name of a famous star, a Hollywood star. very few people know the names of the real stars, the stars in the sky. The media tells us everything about the lives of Hollywood stars, but the stories of the real stars are ever more interesting, more exciting, and more relevant to our lives than most of us imagine. Welcome to the fascinating revelations of the secret lives of stars. A night ends and the stars fade. The sun rises as our planet turns us toward it. Sunrise, we say, but it's actually starrise. The sun, at 150 million kilometers distant, is the nearest star to us. Its light takes 8.5 minutes to reach us. It's the light and heat from the sun that allows most life on Earth to survive. Like all stars, it's a giant nuclear explosion releasing vast amounts of energy. The balance between its own gravity and this explosive force shapes it into the disk we see in the sky. Seen in close-up through the eyes of various spacecraft, its explosive nature is very obvious, as is its true size, 1.4 million kilometers across. That's big enough to put 1 million Earths inside. The surface temperature is just over 5,500 degrees Celsius, but at its core, where nuclear fusion occurs, it's around 15 million degrees. The sun is big and bright because we're so close. But what would it look like from the distance of the next closest star to us? Let's do a little star trekking to find out. Using this fantasy warp factor, we've traveled 275,000 times farther than the Earth is from the sun. We're at a multiple star system known as Alpha Centauri. If you know the star patterns, the sky doesn't look all that different than it does from Earth. There's the familiar W shape of Cassiopeia. And here is one extra star. That star is our sun. It's just an ordinary star among the thousands of others in the sky, and it's now 41 million kilometers, or 4.5 light years away from us. Let's boldly go again. This time, we're hundreds of thousands of light years away from the Earth and Sun. We're looking down at the Milky Way, our galaxy, the collection of about 200,000 million stars to which our sun belongs. Our star is impossible to pick out. We know it's about 2/3 of the way out from the galactic center. Just as a forest contains old trees, saplings, dead wood, and new seedlings, so a galaxy contains all types and ages of stars. In some places, new stars are being born. Other older stars are living out their lives, often in groups. And there are remnants of once mighty stars that are no more. You might ask, how do we know so much about these very distant objects? A rainbow holds a clue. Rainbows form when sunlight passes through drops of water in the atmosphere. The water breaks up light into its individual colors. Visible light is just a tiny part of the radiation we can observe from distant stars. The spectrum. Studying a star's spectrum can reveal many of its secrets. In this manner, we know that stars vary considerably, both in size and temperature, and that these traits are related to a star's composition, age, and most importantly, its mass. Massive stars have short lifetimes, while the least massive have amazingly long lives. Live fast, die young is the rule here. Most numerous are stars smaller and cooler than our sun. Some can live for trillions of years, consuming their nuclear fuel, hydrogen, very slowly. Our own sun, larger, hotter, and brighter, will use up its fuel over 8 to 10 billion years. This star named Sirius, with twice the sun's mass and 26 times brighter, will last only hundreds of millions of years. It's the brightest star in our sky, but only because it is a mere 8.5 light years away. This star is nearly 100 times further away, has 20 times the sun's mass, and is 40,000 times brighter. It will live only for tens of millions of years. Some stars with lifetimes of only 1 million years or less could be up to 150 times the mass of the sun. Probably the biggest well-known star is Antares, a red giant which, if placed in the solar system, would engulf all the planets as far out as Jupiter. It's a star near the end of its life, a stellar time bomb, a future supernova. From Earth, Antares is a brilliant red star in the constellation of the Scorpion. It lies in the direction of the center of our Milky Way galaxy. Seen through the eyes of giant space telescopes, the vibrant central region of our galaxy contains vast clouds of cool gas, dust, young stars, older stars, and the debris of dead stars. This is the still expanding remnant of a star that exploded as a supernova thousands of years ago. In Earth's sky, it covers an area as wide as 80 full moons. This more compact remnant is of a massive stellar explosion that occurred 400 years ago. A supernova is the explosive death of a star. Its fuel consumed, energy creation stops. The star collapses, then rebounds to blow itself to pieces. It's supernovas that form the heavy elements of the universe, elements needed for our planet, our technologies, and our bodies. If the star is not massive enough to form a black hole, a tiny spinning neutron star forms, just a few tens of kilometers across. It has tremendous gravitational and magnetic fields. As it spins, we get a rotating beam of radiation, a series of pulses, hence the name pulsar. This star, Rigel, is a prime candidate for self-destruction relatively soon as stars go. It's a supergiant about 800 light years away and 70 times the width of our sun. From an imaginary airless world hundreds of million kilometers distant, Rigel would be a breathtaking sight, as brilliant as 40,000 suns. Closer now, the view is awesome. Observations show that Rigel appears to be billowing great amounts of its material far out into space. This continuous loss of its mass just might prevent Rigel from exploding and enable it to end its days as a tiny white dwarf star surrounded by a vast nebula. So while it is still there, why not catch it in the famous constellation of Orion? This churning mass is Betelgeuse, a red supergiant star second only in diameter to Antares. Betelgeuse also is in the last moments of its life. It could explode any time between now and the next few million years. When this happens, Betelgeuse will become nearly as bright as the full moon. Betelgeuse is located opposite Rigel in the shoulder of Orion. A cloud of gas in space is called a nebula, and the one in Orion is the brightest in our sky. It's the home to hundreds of young stars, most just a few million years old. Radiation from these hot young stars causes the gas to glow and sculpts the canyons and towers within the cloud. Many stars here are surrounded by dark disks of material, perhaps early planetary systems. From a planet within this stellar nursery, brilliant young blue stars would dot the sky. They would shine like celestial gems against the surrounding gaseous clouds. Five times more distant than the Orion Nebula, this is the famous double cluster in Perseus. The clusters are about 300 light-years apart. These are young stars, no more than 14 million years old. In 100 million years, they will open up more and could resemble the famous Pleiades star cluster, better known as the Seven Sisters. From some of the youngest stars, we move to some of the oldest, far older than even our galaxy. When the Earth was forming almost 5 billion years ago, these stars were already 7 billion years old. These oldest stars are found in globular clusters, the spherically shaped collections of stars that orbit outside the center of our own galaxy and many others. They contain many densely packed millions of stars. From an imaginary planet in a globular cluster, perhaps 13,000 stars would dominate the sky. Planets here are extremely rare. Stars have not exploded to form the heavy materials needed for planetary formation. In the constellation of Auriga lies an intriguing star, Epsilon Aurigae. As seen from Earth, every 27 years, a strange eclipse occurs. The star dims and brightens over a 2-year period. From nearby, it must be an amazing sight as a huge dark disk, 800 million kilometers across, passes in front of the central star. The Spitzer Space Telescope revealed its secret. A huge dark disk surrounding another orbiting companion star. The disk is apparently composed of very small particles about the size of a grain of sand. This material may have accumulated from the parent star that is actually dying, even though it's shining as brightly as 140,000 suns. Stars whose light output changes are called variables. Algol in Perseus was the first eclipsing variable star to be discovered. On Earth, its constant winking led to the name the Demon Star. Measurements of its regular changes led to the discovery that it is actually two stars regularly passing in front of each other as seen from Earth. So close are these stars, about 8 million kilometers, that one is pulling material away from the other, and the whole system is active with radio and X-ray flares. Unlike Algol, Mira is variable because it actually changes in size. It brightens and dims by a factor of 1,000 over an 11-month period. Later in its life, our sun will behave like Mira, both ending as tiny white dwarf stars, even smaller than the Earth. As it moves through space, Mira is losing material that forms an immense gas trail over 14 light-years in length. It has a distant orbiting companion around which planets may be forming. Although no Earth-like planets have yet been discovered, hundreds of planets have been found orbiting nearby stars. It seems that star and planet formation go hand in hand. Planets in distant galaxies are too far away to be detected, but signs of star formation are easy to find. In the October skies from Earth, we can see, even with the unaided eye, the nearest big galaxy to us, Andromeda. Perhaps twice the size of our own Milky Way, it takes 2.5 million years for its light to reach us. Close images of the Andromeda galaxy clearly show the great clouds of gas and dust where stars are forming. In this small galaxy, the clouds with glowing pink hydrogen gas are easily visible. In galaxies near and far, these telltale signs of star formation can be found everywhere, as can stars in every stage of their lives. These observations show that our ideas about the secret lives of stars hold true throughout the visible universe. We're back in our own galaxy now, looking at the biggest star-forming region near us. About 1,200 light-years from Earth is this giant cloud of gas, dust, and young stars. Astronomers call it a molecular cloud. It covers a large part of the area around Orion. This cloud, 5 times farther away than the Orion Nebula, is bursting with the light and energy of young stars hidden within. This immense cloud could stretch from our sun to the nearest star. From afar, these clouds look dense, but in reality, they are almost a vacuum, and so can be easily pushed and pulled. The exact mechanisms that give birth to stars are not fully understood. It's believed that nearby exploding stars have a role to play in this process. Their shock waves are thought to trigger the gradual compression of the hydrogen-filled molecular clouds, pushing them closer together. Over time, as gravity collapses the clouds even more, their core temperature and pressure get so high that nuclear fusion occurs. In this process, hydrogen atoms fuse to form helium, releasing enormous amounts of energy. Often, these young stars shoot great jets of material into space. At some point, the outward explosive force of fusion and the inward pull of gravity balance each other, and a star is born. Cooler materials around the young star then start clumping together to form the bodies we call planets. They differ from stars in that they don't generate heat and light through nuclear fusion. They only reflect light from their parent star. Here, the Hubble telescope reveals a newly forming star system in this 3.5 light-year long finger of molecular clouds. The jets from a young hidden embedded star reveal its presence. After millions of years, such star-forming regions would look like this, the Rosette Nebula. Hot young stars emerging from the dusty, gaseous cocoon in which they first ignited. Multiple star systems are very much the norm. Some make the most unusual scenes in the universe. This twin system in the constellation of Lyra, has two stars orbiting so close that their mutual gravity has distorted their shapes. Material exchange between the stars forms a complex spiral, winding around the companions and swirling through space. But not all companions get along so well. A few years ago, a dim star suddenly became 600,000 times brighter, its light gradually illuminating nearby gas clouds. This was a stellar collision on a Hollywood scale. We had just witnessed a real cosmic smash-up as two stars plowed into each other with brilliant results. In certain systems where material is being pulled off one star onto the surface of another, massive nuclear detonations can occur. So let's move to a safer distance. This looks like the scene of a stellar detonation, and although this is the ghostly shroud of a dying star, it is not the result of an explosion. It formed slowly over many tens of millions of years. Speeding up time over the next few billion years, the sun will change as the nuclear process in its core alters. Gradually, it will swell up, perhaps getting up to 150 times bigger than it is today. It will spread more and more heat through the solar system. Ice worlds will melt, and the atmospheres of the giant gas planets may boil away. Earth's oceans will vaporize, and our planet will be transformed into a broiling desert. Fortunately, we will have a few billion years to prepare for this, but it will certainly be the end for our blue planet. All over the heavens, we can see the remnants of stars like the Sun. Called planetary nebulas, these spectacular formations are made by the gases that once formed the star's atmosphere. Immense stellar winds blast much of its outer atmosphere into space. In the center of each, a small hot star, a few thousand kilometers across, what astronomers call a white dwarf. It's all that remains of the original star's core. In the last few billion years of its life, the dying sun will transform the region of space surrounding it. Outflowing gas will form a spectacular glowing cloud, a stellar shroud of immense proportions. Deep inside will be the remnants of worlds we call the solar system, and a cosmic ash ball that was once the sun. The life of our star will end, not with a colossal bang, but with the creation of a magnificent stellar tomb, a fitting monument to the star that gives us life. Fortunately for us, the death of our sun is billions of years away. We have many more sunrises and sunsets to enjoy. A sunset is simply the Earth turning us away from our star. Sunset gives birth to another night, another chance for us to peek at, to explore, and to marvel at the secret lives of stars.
Okay, so that wraps our presentation. Hopefully you can hear me. I'll bring the volume down here. I have to run out the credits. It's the one requirement that they ask us to do when we're doing a show like this. I didn't see any questions in the question and answer like that, but I did put some links in the video. Hey, look, I can see video from everybody. Yay, okay, that button worked. Whatever, I don't know if it was because you switched hosts back and forth or something like that, Brian, but whatever it was, you got it going, so that's great. Yeah, so again, this show's almost 10 years old, as you can see from the credit there. We'll just end that now because we've satisfied our contractual responsibilities. It's sort of a good recap of all the dots that we see at night. Each one is a sun at a different stage in its life, and there are some really cool naked eye tours where you can look at these different stars and see them at different distances and see the whole life cycle of stars from beginning to end. So that's a fun thing to do. That's my presentation, and again, if you have any other questions, you can always drop us a line. But yeah, I'll turn it back over to you, Brian.
Okay, thank you, Scott. That was excellent. The audio came out really clear.
Oh, good.
All right, so that will conclude. We'll stop it right there, and we'll start the Boston Pizza. I'm pretty sure a lot of people are anxious. I need a drink after this. But thanks for the panelists for showing up, and hopefully we'll see you at the Boston Pizza. That will conclude our meeting for June the 12th. Thanks, Scott. I have to go grab mine very soon. All right, so I'm going to end this right now, and I have to start the other meeting before I can do this. All right, so thanks again for the panelists joining us. All right.
Thanks, everyone. Talk to you soon.
Thanks.